following reactions. Thermodynamic data supplied are not for the standard state. During the first reaction, solid carbon reacts with water vapor and produce gaseous carbon monoxide and gaseous hydrogen. During the second reaction, gaseous carbon dioxide reacts with gaseous hydrogen and produce gaseous carbon monoxide and water vapor. Enthalpy change and entropy change of these two reactions are given. Question number 1. Calculate enthalpy change and entropy change for the reaction 2 gaseous carbon monoxide produces solid carbon and gaseous carbon dioxide. State giving reasons whether the sign of delta S agrees with the reaction taking place. First, we need to calculate delta H and delta S for this given reaction. Secondly, we need to find the sign of delta S agrees with the reaction taking place. Enthalpy change or entropy change can be calculated using a thermochemical cycle or thermochemical equation method. You have to choose which method is convenient by looking at the given data. Therefore, according to the given data, I will choose thermochemical equation method to get the answer. For that, we have to write down the given thermochemical equations with their enthalpy change and their entropy change. During the first reaction, solid carbon reacts with water vapor and produce gaseous carbon monoxide and gaseous hydrogen. Enthalpy change of this reaction is 130 kilojoules per mole and entropy change is 140 joules per Kelvin per mole. During the second reaction, gaseous carbon dioxide reacts with gaseous hydrogen and produce gaseous carbon monoxide and water vapor. Enthalpy change of this reaction is 40 kilojoules per mole. Entropy change of this reaction is 50 joules per Kelvin per mole. We will label this as reaction number 2. During this thermochemical equation method, you can either add these two reactions or subtract these two reactions to get this equation. Carbon monoxide produces carbon solid and CO2 gas. Therefore, if you add these two equations, there is a possibility of getting 2 carbon monoxide on one side and carbon solid and carbon dioxide on one side, because water vapor is cancelled out as well as hydrogen gas is also cancelled out. Just add equation 1 and 2. Then we can write carbon solid plus H2O gas. Then from the second equation, CO2 gas, then H2 gas. Then we will move to the products. From equation 1, we can write carbon monoxide gas, H2 gas, and from the equation 2, again carbon monoxide gas and H2O gas. Now H2O gas you can cancel out as well as H2 gas. Then we can write the same equation. Carbon solid plus CO2 gas produce 2 carbon monoxide gas. Now we will move to the enthalpy change of this equation. When you add these two equations, the enthalpy change delta H3 is equals to delta H1 plus delta H2. Therefore, we can write delta H3 equals 130 plus 40. kilojoules per mole. Therefore, enthalpy change of this reaction is 170 kilojoules per mole. Next, we need to calculate the entropy change of this new equation. For that, we need to add entropy change of the first reaction and the entropy change of the second reaction. Or in other words, delta S3 equals delta S1 plus delta S2. We can write 140 plus 50 joules per Kelvin per mole. Therefore, entropy change of this equation is 190 joules per Kelvin per mole. Now students, we can compare these two equations. The question asks about the enthalpy change and the entropy change of the given equation. 2 carbon monoxide produces solid carbon and carbon dioxide gas. But what we have derived is solid carbon and carbon dioxide produces 2 carbon monoxide gas. So this reaction is the reverse reaction of what they are asking. Therefore, we have calculated the enthalpy change and the entropy change of the reverse reaction. When a chemical reaction is reversed, the value of enthalpy change as well as the entropy change are also reversed in sign with the magnitude remaining the same. Therefore, enthalpy change of this reaction is negative 170 kilojoules per mole. Entropy change is also negative 190 joules per Kelvin per mole. Next, the question asks you the sign of delta S agrees with the reaction taking place. When randomness increases, entropy of the molecules increases and therefore the sign of entropy change is positive. When randomness decreases, entropy of the molecules decreases and therefore the sign of entropy change is negative. Gaseous molecules have the highest randomness or highest entropy and the solid molecules have the lowest. Now, check the number of moles of gaseous reactants and gaseous products. 2 moles of gaseous reactants produce just 1 mole of gaseous products. Therefore, number of moles of gaseous molecules are decreased when the reaction proceeds. That means randomness decreases during this reaction, or we can say entropy decreases during the reaction proceeds. For these types of reactions, entropy change has the negative sign. The calculated value of entropy change is also negative. Therefore, the sign of delta S agrees with the reaction taking place. Now we will write down the answer. Number of moles of gaseous molecules decrease when the forward reaction progresses. This decreases the entropy of the system. Therefore, the sign of entropy change is negative. This is the answer for the question number 1. Question number 2. By means of a suitable calculation, predict whether the reaction given in part 1 above is spontaneous at 27 degrees Celsius. Spontaneity of a given equation is determined by the sign of delta G. Therefore, we need to calculate the value of delta G. To that, we need to use the equation delta G equals delta H minus T delta S. Please do not use the standard symbols because This reaction is carried out at 27 degrees Celsius, and this is not the standard condition. You won't get marks if you use these standard symbols. Now, substitute values for this equation. Enthalpy change is negative 170 kilojoules per mole minus temperature is 300 Kelvin times entropy change is negative 190 joules per Kelvin per mole. The unit of enthalpy change is kilojoules per mole. Therefore, the unit of entropy change has to be converted to kilojoules. For that, you can divide 190 by 1000, or we can write 190 times 10 to the negative third kilojoules per Kelvin per mole. Negative 170 plus 57. The final answer is negative 113 kilojoules per mole. This is the Gibbs energy change of the above reaction. The sign of delta G is negative. Therefore, this given reaction is spontaneous. This is the answer for the question number 2.